Hello everyone. Hello to all of you. Good evening Dadan. Good evening to all of you. Everyone please confirm beta. Good evening Ria. Please confirm beta, am I audible, am I visible clearly to all of you? Audio video is clear to everyone. Good evening Pooja. Everyone please confirm in the chat box, am I audible, am I visible clearly to all of you? Audio video is clear. Very good. How are you all? How are you all? Okay, don't worry. Recording is available. Recording is available for the last lecture. So if you have missed any part, you can complete. Just after this class, you can complete the discussion. So I hope you all are good and preparing well for your exam. Or in the last class, we have covered what are the various measurements that we are going to perform in the case of compass surveying. That was the discussion. And now we are going to discuss the very important topic. So the duration of this class will be of 1 hour. So we will complete this class by 10:30, and we are going to discuss the topic that is the local attraction. So very important topic. You can expect from this question. We will also practice the question. We will also practice the question based on this concept, and the topic is local attraction. So let's see the discussion. Let's see the discussion. What do you mean by the local attraction? So in this lecture, we will cover the concept of the local attraction and how we can find out the error due to the local attraction, or if there is any error due to the local attraction, how we can find out the suitable correction, or ultimately how we can apply the correction. Yes, you can understand the concept. This is the totally new concept. So at the last you have left the class, na Dadan? So in the last class, the concept that we are going to use from the last class, the concept that we are going to use in this class, that is the difference of fore bearing and back bearing of any line is equal to 180 degree. So I hope you have attended that part. For any line, the difference between the fore bearing and the back bearing will be equal to 180 degree. How we can define the fore bearing, how we can define the back bearing, that all things we have covered in the last lecture. So have you attended that part? Have you attended that part where we have drawn this important conclusion that the difference between the fore bearing and the back bearing of any line will be 180 degree? That concept is required. That concept we are going to use to understand the concept of the local attraction. Okay, don't worry, I will repeat. If you have missed, I will repeat. So don't worry for that. So we are going to see the concept of the local attraction, and we will find out the error. We will find out the error and the correction required for the local attraction, and how we can apply the correction, that we will also discuss. So what do you mean by the local attraction? What do you mean by the local attraction? Listen carefully. This is your compass. For example, this is your prismatic compass. In the in the case of prismatic compass, there was a graduated ring. In the case of prismatic compass, there was a graduated ring. Was something like this, yes or no? So this was your graduated ring. I think you all should agree that this ring is the magnetic ring. This ring is the magnetic ring, yes or no? This ring is magnetic ring, yes or no? Yes, you are correct. You have mentioned the definition of the fore bearing, and that is correct. So this was the magnetic ring, yes or no? With the help of this ring itself, we have located the magnetic meridian. With the help of this ring, we can locate the magnetic meridian, and that magnetic meridian we can use as a reference. That magnetic meridian we can use as the reference for the measurement of the bearing. Yes or no? So, if we are able to locate the position of the magnetic meridian correctly, If we are locating the magnetic meridian correctly, can I say in that case we will measure the magnetic bearing? Our measured value of the magnetic bearing will also correct. If we can locate the position of the magnetic meridian accurately or correctly, in that case we can also measure the magnetic bearing of any line with accurately, with higher accuracy, yes or no? But what if? But what if we are not able to measure the, if we are not able to locate the position of the magnetic meridian accurately, then what will happen? With the incorrect reference, you will get the incorrect observation. Yes or no? So, for example, this was the prismatic compass and there was a magnetic graduated ring. If there is any object, that is having the or possessing the magnetic characteristics, and that object is near to the compass, if there is any object that is locally available, that is nearby the compass, can I say it will disturb the this magnetic needle or ring? Because all these objects are having the magnetic characteristics. All these objects are having the magnetic characteristics, and due to the availability of these objects, there will be the disturbance in the magnetic ring. So what will happen? Let's see. So let's say there is no object nearby the compass. There is no magnetic object nearby the compass. So with the help of the compass, you are locating this position as the magnetic meridian. If there is no object, if there is no magnetic object, at the end when the needle or when the ring will get settled, so with the help of that graduated ring, we can find out the position of the magnetic meridian. And for example, there is any line, let's say this is the line OA, for which you want to measure the magnetic bearing. So we will measure this angle and we will say this theta is going to be the correct magnetic bearing of line OA. Yes or no? There were no object. Due to the non-availability of the object, we have located the magnetic meridian correctly. And now we are considering this magnetic meridian as a reference. And for the line OA, we can measure the magnetic bearing, and we will measure the bearing from the north in the clockwise direction. And simply we can say this theta is going to be the correct magnetic bearing of the line OA. Yes or no? But let's say if there is any object which are having the magnetic characteristics, now under the effect of these objects, under the influence of these objects, this needle is going to get disturbed, and let's say this needle stables at this position. If we are considering this as a magnetic meridian, this can we say this is the incorrect position of the magnetic meridian. This is the incorrect position of the magnetic meridian. And why it is incorrect? Because due to the availability of these objects, this is the position, or you can say this is the incorrect position of the magnetic meridian. And if we consider this position of the magnetic meridian and we are measuring this angle, let's say this angle is alpha, so can I say alpha is going to be the incorrect magnetic bearing of the line AB, of the line OA? Yes or no? If our reference is not correct, how we can measure the correct bearing? How we can measure the correct bearing? So let's say this is the case 1 that we have discussed. there is no as such fixed point that always we will get the magnetic meridian on the eastern side, on the western side, sorry. Under the influence of these objects, you may get the position of the magnetic meridian like this. One more, let's take one more case. So let's say this is the example number 2, and here this is the magnetic meridian. Yes or no? Any position you can get. So if we are measuring this angle for this magnetic meridian, let's say we are measuring this angle beta, again we will say beta is going to be the incorrect magnetic bearing of line OA. So with the help of this example, I have considered 3 cases. So case 1, when there was no local attraction. In case 2, due to the local attraction, this yellow example, this yellow line, due to the local attraction, magnetic meridian shifts towards left side, you can say, or you can say on the west side. And third example I have considered, due to the effect of the local attraction, magnetic meridian shifts towards right side or east side. I think these 3 cases are clear. So this is your case 1, when there was no effect of the local attraction. We were defining the correct magnetic meridian, and with the help of the correct magnetic meridian, we can measure the correct magnetic bearing of the line OA. In the second case, due to the effect of the local attraction, this was the case yellow line. Our magnetic meridian shifted towards the west. And this is the third case. When due to the local attraction, our magnetic meridian shifted toward east. I think we have considered all the possibilities. Due to the availability of the local bodies which are having the magnetic characteristics, what will be the various possibilities? In this example, we have considered all the possibilities. Our incorrect magnetic meridian may be on the east side. Our incorrect magnetic meridian may be on the west side. Yes or no? So, can I say, due to the local attraction, there will be the error in our measurement? Due to the local attraction, there will be the error in our measurement. Let's talk about the case 1. So if I talk about the case 1, there will be no error. There will be no error in our measurement. Yes or no? There will be no error in our measurement. Let's say if I talk about the case 2, when magnetic meridian shifts towards the west. So how we can define the error? Error will be equal to measured value minus true value. Let's refer this diagram. Consider this yellow line. So what value you are measuring? You are measuring the alpha. Your measured value is going to be alpha, and the true value is going to be theta. True value is going to be theta. Can I say from this diagram it is clearly visible? From this diagram it is clearly visible that alpha is greater than theta. Yes or no? If our position of the magnetic meridian gets shifted towards the west, in that case, our measured value is going to be always greater than the true value. Yes or no? So can I say, in this case, there will be the positive error. In this case, there will be the positive error due to local attraction. Due to local attraction. Yes or no? Similarly, if I talk about the case 3, when magnetic meridian shifted towards the east, consider this pink line. So now I can write For this case, error will be equal to measured value minus true value, and our measured value is going to be beta and true value is going to be theta. No need to remember anything. Just try to understand only. No need to remember anything. Once you will get the concept, these things are not required. So do not remember all these data alpha, beta, theta, gamma, x, y, z. So as I can refer from the diagram, when the magnetic meridian shifted towards the east, our measured value is going to be always less than as compared to the true value of the measurement, yes or no? Beta will be always less than from the theta, and if measured value is always less than the true value, can I say in this case there will be negative error? In this case there will be the negative error due to local attraction. So what point I want to conclude? Due to the local attraction, there may be positive error, there may be negative error. If the error is positive, we will apply the negative correction, because we know there is a relation between error and correction. There is a relation between the error and correction, and if the error due to the local attraction is negative, we will apply the positive correction. We will apply the positive correction. I hope all these three possibilities are clear to everyone. In this case, error will be equal to measured value minus true value. Measured value is theta, true value is theta, error will be equal to 0. I hope the entire discussion is clear to everyone. So yes, this is the error occurred due to the local attraction. This is the error occurred in our compass surveying due to the local attraction. We can commit there may be the positive error due to the local attraction, or there may be the negative error due to the local attraction. But one more important assumption is there. What we are assuming whenever we will deal with the local attraction, we are considering one very important assumption. When there is error due to local attraction, when there is error due to the local attraction, all other sources of errors are neglected. So if we are saying if there is any error due to the local attraction in our survey work, if there is any error due to the local attraction in our survey work, in that case we are not considering any other source of error. So as we have discussed earlier also, there are various sources of error like instrumental error, like personal error, and like natural source of error. So when we are talking about the local attraction, we are not considering any other error. I hope this assumption is clear to everyone. Means whatever error will be there in our survey work, whatever error, beta, we are talking about the error. We are talking about the error in bearing. We are not talking about the linear measurement. In the case of compass surveying, our main objective is to find out the bearing. Here we have measured only bearing. Is there any term related to the length or the linear measurement? Is there any term that I have considered for the linear measurement or the distance? Answer is no. So local attraction problem will occur. Error will be the local attraction, error due to the local attraction in the case of in your bearings only, not in length. Because length we are going to measure with the help of the chain or tape. Bearings we are measuring with the help of the local attraction, and due to the local attraction, needle was get shifted, needle was get disturbed, due to which we are facing the error in our bearings measurement. I hope you got the point. I hope you got the point, yes or no. So this is the very important assumption. Whenever we will talk about as there is error in the local attraction, we will assume that there is no other error in our survey work. If there is any error, we will consider all that error due to you said all error in survey work will be neglected. I thought linear measurement. I am not talking about the linear measurement. Why you are getting confused? With the help of the compass, we cannot perform the linear measurement, na? When I am talking about the compass survey, when I am talking about the prismatic compass, there will be error on that measurement only, that we are measuring with the help of the compass. And with the help of the compass, we are only measuring the bearing. We are not measuring the distance with the help of the compass. So if any quantity that we are not measuring, how the error will occur? How the error will occur? So there are other source of error in the case of linear measurement, like error due to the standardization, error due to the pull, error due to the temperature, error due to the sag, all those points that we have covered in the previous class. Yes. So I hope this assumption is clear. Whatever error will be there in our compass survey, all that error will be due to the local attraction only. That is our assumption. There is no instrumental error, there is no personal error, or there is no any other source of natural error in our compass survey work. Everyone please confirm if the discussion till now is clear to everyone. If this assumption part is clear to everyone, please confirm in the chat box. So now the next question arises, sir, how I will know? How will I know that there is some error, there is error due to the local attraction in our survey work? How we will know this? Is there any error in our survey work due to the local attraction? Who will tell you? You need to find out. So the first discussion will be related to how we can identify that is there any error due to the local attraction in our survey work. The second part, if there is any error due to the local attraction, we need to find out that error. If there is any error due to the local attraction, we need to find out that error. And the third part, we need to find out the suitable correction for that. So again, I am repeating, whenever I will talk in the entire subject, whenever I will talk about the error and correction, you know very well, we require two things. Whenever I will talk about the error or correction, we required magnitude of the error, we required nature of the error. Similarly, we required magnitude of the correction, we required nature of the correction. Yes or no? Same we have done in the case of linear measurement also. Same we have done in the case of linear measurement also. Whenever we will talk about the error and correction, we required both things, magnitude and nature. Because if we don't know the nature, of the correction, how we can apply the correction? Because the correction may be positive, correction may be negative. So it is very important for us to understand the magnitude and the nature of the correction. I hope the discussion is clear. There is no formula to solve the question related to the local attraction. If you are getting all these basic points, you can solve any question related to the local attraction. So we will follow all the basic concepts. There will be no requirement of any formula. And from this topic, you are frequently getting 2-mark problem in your GATE exam. So let's see. So we will find the error and correction due to the local attraction. But for that, we will discuss some important observations. Now we are going to discuss some important observations. With the help of these observations, we can easily deal the problem of the local attraction. Listen carefully. What is the first observation? For any line, if the difference of the fore bearing and back bearing is not equal to 180 degree, then there must be a local attraction, either at station 1 or at both stations. As we know, for any line, the difference of the fore bearing and the back bearing is always going to be 180 degree. Yes or no? And for any line, if we are not getting the difference of the fore bearing and back bearing as 180 degree, what it implies, what it means? If for any line we are not getting the difference of the fore bearing and back bearing as 180 degree, what it means? Either the fore bearing or incorrect. Either the fore bearing is incorrect or the back bearing is incorrect. Yes or no? There must be some error. That's why you are not getting the difference of the fore bearing and the back bearing as 180 degree. The fore bearing you have measured from the station 1 and the back bearing of this line you have measured from the station 2. Yes or no? Yes. So I am not sure where there is the error, at the station 1 or at the station 2, or both the station is having the error, but we can simply say if we are not getting the difference of the fore bearing and back bearing of any line as 180 degree, we can simply say there must be error due to the local attraction. There must be error in our survey work due to the local attraction. The first observation is clear to everyone? The first observation is clear to everyone, yes or no? The first observation is clear to everyone? Okay. Now let's see the another important observation. If for any line, the difference of the fore bearing and back bearing is 180 degree. If for any line we are getting the difference of the fore bearing and back bearing as 180 degree, what it implies, what it means? If for any line we are getting the difference of the fore bearing and back bearing as 180 degree, what it means, what it implies? Tell me in the chat box. Tell me in the chat box, if for any line we are getting the difference of the fore bearing and back bearing as 180 degree, what it means? There may be two possibility. Listen carefully. There may be two possibility. The first possibility that you people are telling me that both stations are free from the local attraction. Yes. If we are getting the difference of the fore bearing and back bearing as 180 degree, we can simply say, sir, both the readings are correct. Means station A or station 1 or station 2, both are having no error due to the local attraction. Then only we are getting the correct fore bearing and correct back bearing. If for any line the fore bearing is correct, back bearing is also correct, then we will get the difference at 180 degree. But this is only half picture. Yes, this is the possibility one. There is one more possibility. If we are getting the difference of fore bearing and back bearing as 180 degree, there may be one more possibility, and the possibility is both stations are affected by same value. Both stations are affected by same value of the local attraction. Let's take an example. For example, this was the station A and this was the station B. Let's say station A is having the error due to the local attraction as +1 degree, and station B is also having the error due to the local attraction as +1 degree. Both stations are having the same error due to the local attraction. Means whatever fore bearing we will measure from the station A, there will be error of plus 1 degree. There will be error of plus 1 degree. So can I say, let's say, for example, we are getting this value as 21 degree. And the back bearing of this line we are getting measuring from the station B, and this bearing we are getting as 201 degree. That bearing we are getting as 201 degree. Both stations are having the same error. In that case, what will be the difference of the fore bearing and back bearing? What will be the difference of the fore bearing and back bearing? Here also you are getting the difference of the fore bearing and back bearing as 180 degree. So conceptually this may be the possibility. Follow the previous lecture. Doesn't follow the previous lecture. Clear? What is the problem in that? How you are not getting the difference of the fore bearing and back bearing? Let's see. Let's consider any line. It's a very basic concept here. For example, this is the line AB. For example, this is the line AB. From where we are measuring the fore bearing from here. Let's say this fore bearing is theta. See. Let's say the theta is the fore bearing of the line AB. Let's say the theta is the fore bearing of the line AB and alpha is the back bearing of the line AB. Theta is the fore bearing of line AB and alpha is the back bearing of line AB. This point is clear, Dadan? This point is clear, yes or no? This point is clear, yes or no? So if we are extending this line, let's say, if we are extending this line AB like this, so what will be this angle? Tell me. What will be this angle? Dadan will tell me. What will be this angle? If we are extending this line, what will this angle? If this angle is theta, can I say this will also equal to the theta? This will also equal to the theta. Dadan, can you tell me what will be this? What will be this pink angle? 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 Tell me, Dadan. Angle on a straight line. What will be this angle? Alpha minus theta. What will be the magnitude? Yes, 180 degree. So this angle will be equal to 180 degree. So you are saying alpha minus theta will be equal to 180 degree. What is this alpha? Alpha is the back bearing of the line AB. Theta is the fore bearing of the line AB. Will be equal to 180 degree. So if I use the mod, so can I write for any line the difference of the fore bearing and the back bearing will be equal to 180 degree. Now tell how we are getting the difference of any line. For any line, how we are getting the difference of fore bearing and back bearing as 180 degree. Now I think this point is clear to everyone. Now this point is clear to everyone. Okay. So we were discussing some important observation. So if we are getting the difference of the fore bearing, if we are getting the difference of the fore bearing and back bearing as 180 degree, it can have two possibility. But to solve numerical from the calculation point of view, we are going to consider only first possibility. From the calculation point of view, from the numerical point of view, we will always consider the first possibility. So let me conclude. If for any line we are getting the difference of fore bearing and back bearing. We are getting the difference of the fore bearing and the back bearing of bearing is not equal to 180 degree. If the difference of the fore bearing and back bearing is not equal to 180 degree, simply we will say there is error due to the local attraction. Simply we will say if we are not getting the difference at 180 degree, we will say there is error due to the local attraction. And if we are getting the difference of the fore bearing and back bearing as 180 degree, and if we are getting the difference of the fore bearing and back bearing as 180 degree, we will simply say there is no local attraction. We will simply say there is no local attraction. Now I think this point is clear to everyone, but conceptually this may be the possibility. But that possibility we are not considering from our calculation point of view. But conceptually this may be also the possibility that if both the stations are having the same error due to the local attraction, in that case also we can get the difference of the fore bearing and back bearing as 180 degree. We can get the difference of the fore bearing and back bearing as 180 degree. Now I think these two observations are clear to everyone. Now please confirm in the chat box, these two observations are clear to everyone, and based on these observations only we can solve any question related to the local attraction. Based on these observation only we can solve any question related to the local attraction without any problem. Confirm in the chat box, the discussion till now is clear to everyone. Confirm in the chat box, the discussion till now is clear to everyone. Can we move for some more observation? Can we discuss now some more observations? Yes, let's see. So let's see some more observations. Like third observation is also very important observation. If any station is affected from the local attraction, if any station is affected from the local attraction, can I say whatever readings we will take from that stations are going to be incorrect? If any stations is affected from the local attraction, whatever value, how many number of readings that we are going to take from that station are going to be incorrect. If in actual measurement case to happen that in our measurement incorrect, that will not occur. If you are considering the possibility number 2 to solve the numerical problem, you will never able to solve the question. You will never able to solve the question. So that's why we are not considering. That's why we are not considering. Yes, obviously. Clear? So let's see the third observation, and it is very important observation. So let's take the example. For example, this is your station A, this is your station B, this is your station C, and this is your station D. Let's say for example, I am saying in this survey work, station B is having the local attraction. Station B is having the local attraction. Let's say in this 4 station, let us assume station B is having the local attraction. Station B is having the local attraction. Can you tell me what are the various readings that we are going to take from the station B? What are the various readings that you are going to take with the station B? How many readings we will take? How many observations we will take from the station B? How many observations we will take in this survey work from the station B? Absolutely correct. We are going to take 2 observations or 2 reading. What are those readings? What are those readings? What are those readings? So, sir, from the station V, we will measure the fore bearing of the line BC. Yes or no? From the station B, we will measure the back bearing of the line AB. These are the two observations. These are the two readings that we are going to take from the station B. Fore bearing of the next line and back bearing of the previous line. Yes or no? Fore bearing of the next line and the back bearing of the previous line. So what this observation says? Now read. If any station is affected by the local attraction, then all bearing measured from that station will have same value of the error, and hence same correction is also required. Can I say, if station B is having the local attraction, these two readings we have measured from the station B, both readings will have the error, will have the same error, yes or no? Both these readings will have the same error. To correct all these readings, we need to apply the same correction. Yes or no? Both these readings will have the same error, and to correct these two readings, we need to apply the same correction. We need to apply the same correction, yes or no? Yes or no? Tell me in the chat box. Tell me in the chat box. This observation is clear to everyone? This observation is clear to everyone, yes or no? If any station is affected from the local attraction, both the readings are going to have the same error, and for both the readings we need to apply the same correction. Sir, didn't get. Which point you didn't get? Tell me. If any station is having the local attraction, all the readings that we are going to take from that station will have the error, na? Kyo bhai dadan? If any station is having the local attraction, whatever measurements we will perform that station will have the error. Because we are using the station B for the measurement of the fore bearing of the next line. We are using the station B for the measurement of the back bearing of the previous line. So if station B is having the local attraction, so these two readings are going to be incorrect. To find out the correct readings, we need to apply some corrections. We need to apply some corrections, yes or no? How you will correct the incorrect reading? How you will correct the incorrect reading? How you will correct the incorrect reading? By applying certain corrections. By applying certain corrections, because both these readings we are measuring from the same station, that is the station B. That is the station B. Now the point is clear, yes or no? Now the point is clear. Now the point is clear, yes or no? Now the point is clear. Okay. So now let's see the fourth observation, that internal angle, external angle at any station will not be affected by the local attraction. Internal angle or external angle will not be affected by the local attraction. There will be no effect of the local attraction in the internal angle or external angle of the traverse. Clear? So now let's see a problem, how we can apply all these concepts. So this is the question that they have asked in your GATE exam. So this is the GATE 2-mark problem. And this is the best problem from this topic, that is the local attraction. This is the gate 2 mark problem. If you can solve this question, then you can say your all the concepts related to the local attractions are clear. So this is the best question. This is the best question related to the local attraction. Now we will solve this question. Should we start the discussion? Should we start the discussion for this question? Should we start the discussion for this question? So first try to understand this question. What they have asked, first try to understand this question. So read the question carefully. See, following bearings are observed while traversing with a compass. You have performed a compass surveying. You have performed a compass survey, and from the field you have collected some data. From the field you have collected some data. So let's see. AB, BC, line AB, line BC, line CD, line DE, line EA. Can I say from this data we can observe and we can conclude this is the traverse, or you can say this is the closed traverse? Sir, how do you know this is the closed traverse? How do you know this is the closed traverse? Because in this traverse work, A was the starting point and A is the end point. So this survey you have performed in a closed traverse. So for the line AB, you have measured the fore bearing. For the same line AB, you have measured the back bearing. And that bearing you have measured with the help of the compass. That bearing you have measured with the help of the compass. Yes or no? Similarly, for the next line, you have measured the fore bearing and back bearing. In the same way, for all the lines of this traverse, for all the lines of this traverse, you have measured the fore bearing and back bearing with the help of the compass. Now let's read the question. After applying the correction due to the local attraction, in this survey work there is error due to the local attraction. In this survey work there is error due to the local attraction. So after applying the correction due to the local attraction, the corrected fore bearing of the line BC will be, you need to find out the correct value of this bearing. You need to find out the correct value of this bearing. This bearing is incorrect. You need to apply the correction, and you have to tell the what will be the correct fore bearing of the line BC after applying the correction. Question is clear to everyone? Question is clear to everyone? Question is clear to everyone? Tell me. Okay. So now how we can solve this question? Let's understand one by one, step by step. So what we can do? We don't know at which station what is the error due to the local attraction. We don't know, as of now we don't know which station is having what error of the local attraction. And if we don't know the magnitude and nature of the error, how we can apply the correction? This BC you must have measured from the station B, yes or no? This reading you have taken from the station B. If I don't know what is the error at station B due to the local attraction, what was the magnitude of the error, what was the nature of the error at the station B due to the local attraction, how we can apply the correction? This is the question. How we can apply the correction? So if anyhow we can find out the error at station B due to the local attraction. If anyhow we can find out the error at station B due to the local attraction, then we can find out the correction. And then we can apply that correction. Then we can apply that correction to find out the correct bearing of the line BC. what is the first and foremost thing that is required? We need to find out the error due to the local attraction at station B. Yes or no? Just try to understand the approach. The discussion till now is clear. The discussion till now is clear to everyone. Okay. So what we can do, we can check the difference of the fore bearing and back bearing. We can check the difference of the fore bearing and back bearing of all the lines. So let's check. So this is going to be 181 degree, 181 degree 15 minute 0 second. This is going to be 178 degree. Difference is going to be 15 minute 0 second. This is going to be 178 degree 45 minute 0 second. And this is going to be 180 degree. And this is going to be 180 degree 45 minute 0 second. Yes or no? So what we have done, we have simply found the difference of the fore bearing and back bearing of all the lines. Now listen the discussion carefully. For a line DE, we are getting the difference as 180 degree. For the line DE, we are getting the difference of the fore bearing and back bearing, that is 180 degree. That is 180 degree. What it means or what it implies? For the line DE, we are getting the difference as 180 degree. For the line DE, we are getting the difference of the fore bearing and back bearing as 180 degree. What it implies? That means this reading is correct and this reading is also correct. When both the readings are going to be correct, then we are getting the difference as 180 degree. Can we say like this? Can we say like this, yes or no? Just listen the discussion carefully. You are going to get all the concepts related to the local attraction without any formula. Just by knowing the basic concept, you can solve any question related to the local attraction. If the difference of the fore bearing and the back bearing of the line DE is 180 degree, we can say this bearing is correct and this bearing is also correct. Tell me, this bearing you have measured from which station? This bearing 258 degree 30 minute you have measured from which station? This observation you have taken from which station? This observations you have taken from which station? 258 degree 30 minute reading. Yes, this reading you have taken from the station D. What about this reading? What about this reading? 78 degree 30 minute you have taken from which station? This reading 78 degree 30 minute you have taken from which station? This is the back bearing of the line DE. Yes, so this reading we have measured from taken from the station E. So can I say station? What I can conclude? D and E are free from local attraction. Can I conclude this? If these two readings are correct, then only we are getting the difference at 180 degree. This reading we have measured from the station D. This reading we have measured from the station E. Both the readings are having the correct value. That means we can say station D and E are free from the local attraction. Yes or no? Can I also say this? If the station D and E are from the free from the local attraction, if the station D and E are free from the local attraction, all the readings that we have measured from the station D and E will be correct. If the station D and E are free from the local attraction, whatever readings we have measured from the station D and E will be correct. Which readings you have measured in this survey work? Which readings you have measured from the station D and E? Which readings you have measured from the station D and E? Listen carefully. This reading we have measured from the station D. Cross check. This reading we have measured from the station D, and this we have measured from the station E. That means in this survey work, these four readings are correct. That means in this survey work, these four readings are correct. Can I say like this? Can I say like this, yes or no? 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 I hope the discussion till now is clear to everyone. I hope the discussion till now is clear to everyone. Now, tell me, if this reading is correct, if the forebearing of the line EA is correct, what is your doubt? What is your doubt? What is your doubt, Riya? What is your doubt? Ask your doubt, dear. Ask your doubt. Error in the C lead to error in the D. How? I am not saying only these two stations are free from the local attraction. I don't know about the remaining other stations. Because for this line, we are getting the difference of the forebearing and back bearing as 180 degree. On this value, based on this value, I can say these two readings are correct. And these readings we have measured from the station D and E. That means we are just simply concluding one thing: the station D and E are free from the local attraction. This is our conclusion. Station D and E are free from the local attraction. If the station D and E are free from the local attraction, all the values that we have measured from the station D and E are going to be correct. Are going to be correct. अरे ऐसा तो नहीं होगा ना भाई कि अगर किसी स्टेशन पे लोकल अट्रैक्शन है तो एक रीडिंग आप करेक्ट मेजर कर लें और एक रीडिंग आप इनकरेक्ट मेजरमेंट कर लें. ऐसा तो नहीं होगा ना. If any stations is having the local attraction, either all the readings will be correct or all the readings will be incorrect. If any station is having the local attraction, so all the readings are going to be incorrect. If any station is free from the local attraction, all the readings will correct. All the readings will correct. So based on this concept, we have concluded whatever readings we have taken from the station D and E are going to be correct. So these are the readings that we have taken from the station D and E. From each and every station, you are taking the two readings, na? You are taking the two readings. Fore bearing of the next line and back bearing of the previous line. Fore bearing of the next line and the back bearing of the previous line. Yes. Now let's see. If this is the fore bearing of the line EA and this is the correct value, obviously, can I find out the back bearing of line EA? Bolo. What will be the back bearing of the line EA? It should be equal to 212 degree 30 minute minus 180 degree. Yes or no? Because for any line, the difference of the fore bearing and back bearing is going to be 180 degree. So 32 degree 30 minute, this will be the true value of the back bearing of the line EA. But what you are reporting? What you are reporting? What you are reporting? Measured value of EA, measured value of back bearing of EA is 31 degree 45 minute, and this is the true value. Yes or no? So can I say now we can find out the error at station A? Because station E having no error, so there must be error at the station A. This reading you have measured from the station A. This reading you have measured from the station A. So error is the measured value minus true value. So measured value is 31 degree 45 minute, and true value is 32 degree 30 minute. So can I say minus 45 minute? So error is 0 degree 45 minute 0 second minus. This is the error at station A. This is the error at station A. If this is the error, can you tell me what will be the correction required at station A? Plus 0 degree 45 minute 0 second. Yes or no? Means whatever values we have taken from the station A, if we will apply this correction, we will get the correct value. Whatever value we have taken from the station A, whatever value we have measured from the station A, if we are applying this correction, we will get the correct values. Yes or no? This reading you have also taken from the station A. So can I find out correct fore bearing of the line AB? Can I find correct fore bearing of the line AB will be equal to measured value plus correction. Measured value plus correction at station A. Yes or no? And the measured value is 126 degree 45 minute. 126 degree 45 minute plus correction we have found, that is 45 minute. 0 degree 45 minute. So what will be equal to? So this is going to be 127 degree 30 minute 0 second. Yes or no? Yes or no? Can I find out the correct back bearing? Correct back bearing of the line AB, and that should be equal to correct fore bearing plus 180 degree. So 127 degree 30 minute plus 180 degree, that should be that correct back bearing. So 127 degree 30 minute plus 180 degree, that is going to be 307 degree 30 minute. Yes or no? So this is going to be the true value, and we are having the measured value as 308 degree. We are having the measured value as 308 degree. So can I find out the error at station B will be equal to measured value minus true value. So measured value is 308 degree and the true value is 307 degree 30 minute. So this is going to be 0 degree 30 minute 0 second. Error you are getting as positive. Error you are getting as positive. So can I find out the correction at station B is going to be the minus 30 minute. Again the same concept. Again the same concept. Whatever readings we have taken from the station station B, if we apply this correction, we will get the correct bearing. Yes or no? So can I write correct fore bearing of line, correct fore bearing of line BC will be equal to, so this is the measured value plus correction at B. Yes or no? प्लस माइनस कर देंगे तो मेजर्ड वैल्यू इज 49 डिग्री 15 मिनट 49 डिग्री 15 मिनट and correction at B was minus 30 minute. Minus 30 minute. What this value will come? So 49 degree 15 minute minus 0 degree 30 minute. So this is going to be 48 degree 45 minute. This is going to be the correct forebearing of the line BC. That will be the correct back bearing of the line BC that they have asked 48 degree 45 minute. So based on this explanation, you can find out the correct forebearing of the line BC like this. In this way, you can find out the correct forebearing of the line BC. For each and every station, first we need to define the error. What is the magnitude of the error and what is the nature of the error. Then, if we know the magnitude and nature of the error, we can apply the suitable correction to get the correct bearings. To get the correct bearings. So, we don't have use any formula. Here we need not to use the any formula, but with the help of all the basic concepts and observation. With the help of all the basic concepts and the observation, we can solve any problem related to the local attraction. All the basic things that we have used to solve this question. All the basic things that we have used to solve this question, with the help of the difference of the forebearing and back bearing, we have just know what are the stations that are not affected from the local attraction, and the difference of the forebearing and back bearing of any line is equal to 180 degree. If we know the forebearing, we can calculate the back bearing. If we know the back bearing, if we can calculate the forebearing. With the help of this concept, that forebearing and back bearing, the difference of the forebearing and back bearing of any line will be equal to 180 degree. We have used that same concept. We have used that same concept. So everyone please confirm in the chat box, the discussion for this question is clear to everyone, yes or no? Everyone please confirm in the chat box, the discussion for this question is clear to everyone. So this was the best question that you will find from this topic, that is the local attraction. So in this way, we have completed our discussion for the local attraction. All the concept part we have covered, all the important observations we have discussed, as well as we have also completed a numerical problem based on the local attraction. So if anyone having any doubt, any query at any concept, you can ask your doubt. Otherwise, we have completed the discussion for the local attraction. So please confirm in the chat box, the discussion about the local attraction is clear to everyone. Please confirm in the chat box, the discussion about the local attraction is clear to everyone. The discussion about the local attraction is clear to everyone. So this was all about for this class. So now you are in the position, you can start practicing the PYQs. You can start attempting any question from the compass surveying. So here we have completed our discussion for the compass surveying. From the next class, we are going to start our next chapter, chapter number 4, and that will be the traverse surveying. So as of now, we have completed total 3 chapters. First chapter was fundamental of surveying, that we have completed. Second chapter was linear measurement, and the third chapter was compass surveying. Fourth chapter that we will start in from the next class, and that will be chapter number 4. This will be the traverse surveying. This will be the traverse surveying. So keep revising your concepts and keep practicing the question of all your previous year of GATE and ESE. So this was all about for this class. Thank you everyone. Keep learning better. Thank you.